Good morning to one and all present here. Welcome, dear students. Today we shall begin with the new chapter, that is Composition of Matter, chapter number 6, part 1. So let's begin. Before that, answer me some questions. Okay, children? What are the various states of matter? Think about it. Yes, children? So, the answer is the various states of matter are solid, liquid, and gaseous state. Now, what is the difference in ice, water, and steam? Can you find the difference here, children? Ice, water, and steam are in different state, that is solid, liquid, and gaseous. Isn't it, children? What are the smallest particle of matter called? We have already learned about this in our previous standard, children. So can you tell me now? Yes, the smallest particle of matter are called atoms. Now, what are the types of matter? The types of matters are elements, compounds, and mixture. Yes, children? Now, let's do an activity. Take some mustard seeds in a transparent plastic jar. Thread a long thread at the center of a big balloon by means of a needle and tie it tight. Stretch this rubber diaphragm and fix it on the mouth of the jar by means of a rubber band. Pull the diaphragm up and down with the help of the thread, first slowly, then with moderate speed, and then vigorously. Record your observation. Now this is the table we have on page 39 of our textbook. There are two columns. In first column it is the mode of pulling the diaphragm up and down, and in the second column movement of the mustard seeds. Now first it is slow. So the movement of mustard seeds are vibrations happen in the same place. Now what if the pulling of diaphragm is with moderate force? So the movement of mustard seed would be the vibrations at different places. And if the diaphragm is pulled vigorously, so the movement of mustard seeds would be, the vibration would be all over the jar. Got it, children? Now, on the above experiment, we give energy less or more to the seeds by pulling the diaphragm up and down, making them move differently. Now the particles in solid, liquid and gaseous states of matter have movement somewhat similar to that. An intermolecular force of attraction acts between the particles of matter. The extent of particle movement is determined by the strength of this force. The particles of solid are very close to each other and vibrate at the fixed position. Understood, children? As you can see in this picture also. The particles of solid are very close to each other, whereas in liquid it is little far, and in gases it is very far from each other. Due to this, solids get properties like definite shape and volume, and also have high density and non-compressibility. Density means compactness and non-compressibility means cannot be reduced in size by pressure. The strength of intermolecular force is moderate in liquid state, though it is not strong enough to fix the particles in definite position. It is strong enough to hold them together. As a result, liquids have definite volume. However, they have fluidity and their shape is not definite but changes accordance with the container. That means if the water is placed in a jar, it will take the shape of that jar. And if the water is kept in a water bottle, so it will take the shape of a water bottle. Understood, children? Okay. The intermolecular force is very weak in gases. Therefore, the constituent particles of gases move freely and occupy all the available spaces. Look at the picture, children. You can find out here that the particles in the gases are far away, so the intermolecular force is very weak in gases. Okay, understood? Now, consequently, gases have neither definite shape nor definite volume. So, this was the diagram of interparticle distance. Understood, children? Now see, we have one more presentation here where we have these three pictures. The first one is solid, where the particles are very close to each other, and in liquid they are little far, whereas in gases those are very far from each other. Now children, on page number 40 we have this table given where it shows the characteristics of states of matter. First one is the physical state of matter, where we have solid, liquid and gases. So the different properties are fluidity, rigidity, plasticity or elasticity. Second is volume, shapes, compressibility, intermolecular force and distance between particles. So first we will see about solid. So they are rigid, plastic or elastic. Rigid means they are firm. Okay. Now their volume is also definite and they also have a definite shape. Compressibility, that means it is negligible. That means some solids can be reduced to another size, and the intermolecular force is strong, and distance between the particle is minimum. Okay, now moving next to liquids. Now they are fluid, isn't it? And their volume is definite, but their shapes are indefinite. That means they don't have a definite shape. Compressibility is very small, and the intermolecular force between liquids are moderate. Similarly, the distance between the particles is also moderate. Now the next we have gaseous, where it is a fluid. Gaseous or gases, they don't have a definite volume nor a definite shape, and the compressibility is very high. Intermolecular force in gases are very weak, and the distance between the particles is also very large, as you can observe these properties in the picture above the table. So these are some characteristics of matter, of solid, liquids and gases. I hope children you are finding it easy to understand the concept, the characteristics of states of matter. Yes children? Is it easy to understand? Yes. Very good children. Now let's move ahead. So now children, on page number 40 of your textbook, we have this table where there are 3 columns. In the first column is name of material, second chemical formula or composition, and the third column we have type of matter. So the first material we have is water. So what is the chemical formula? H2O. So which type of matter it is? It is a compound. Now carbon. The chemical formula is C and it is an element. Now children, compound means where there are more than one element. In water we have hydrogen and oxygen. So it is a compound. Whereas in carbon there is only carbon, C. So it is an element. Okay children. Now next is oxygen. Now tell me children, is it a matter? Which type of matter would be? It will be element, compound or mixture? So oxygen, the formula would be O2 and it is a element. Now air. Air is a mixture of gases. It is having hydrogen, oxygen, nitrogen, carbon dioxide and other gases. So it is a mixture. Now children, you have to find out aluminium, brass and carbon dioxide. Okay. Will you do it for me? Yes children. Now this is the second method of classification of matter. In this method, the criterion used for classification of matter is chemical composition of matter. We have seen in our previous standard that matter is classified into 3 types, and those are elements, compound and mixture. by considering whether the smallest particle of matter are similar or different and what are they made of. All the smallest particles, that is atoms or molecules in an element or a compound, are alike. However, the smallest particle in a mixture are of two or more types. The smallest particle of an element contains identical atoms. For example, each molecule of oxygen contains two oxygen atoms in bonded state. The smallest particles of a compound are formed by joining two or more types of atoms to each other. For example, each molecule of water contains two hydrogen atoms joined to one atom of oxygen. Are you understanding this, children? The smallest particles of a mixture are atoms or molecules of two or more elements or compounds. For example, the main constituent molecules of the mixture, namely air, are nitrogen, oxygen, H2O, CO2. Similarly, the mixture brass contains atoms of copper and zinc, while bronze contain atoms of element copper and tin. Understood, children? So let's take a quick summary of what we have learned. What is matter? Anything that has mass and occupies space is called a matter. What are the three states of matter? There are three types of states of matter: solids, liquids, and gases. Isn't it? Solids, they are rigid. They have fixed shape and fixed volume. Liquids, they are not rigid. They don't have fixed shape nor fixed volume. Gases, they are not rigid. They don't have fixed shape nor they have fixed volume. Yes? Now, atoms. All matter is composed of atoms. And children, atoms are the smallest particle of an element. Understood? Very good. Let's take a look on the notes. As you all know, first we write new words and then we write glossary, the scientific meaning of the word. Followed by question number 1, choose the correct option and fill in the blanks. Second question is, state whether the following statements are true or false. Followed by question number 3, define the following terms. Question number 4, answer in one sentence. Question number 5, give scientific reason for the following statements. Question number 6, write the composition of the following materials by means of chemical formulae and classify them accordingly. So you need to make a table of 3 columns: name of material, chemical formula, composition, and types of matter. So these were the notes for today's topic. So children, That's all for today's session. We will continue in our next session. Till then, thank you.